So this is a good lesson for us to be utilizing technology. So if you have a TI-84 calculator or something equivalent to it, you want to get that out. We're going to be graphing a radical equation, and we're going to find its solutions through graphing. There are some advantages to doing it this way. There's some drawbacks, just like everything in math. So you have to decide as to what tools you have available to you. And then you're going to be responsible as a student for all methods of solving. This is just one of them. So we will revisit the concept of solving these when we get to the quadratics unit, because I'm going to show you the algebraic way to solve them. And then you'll see the differences, and you might have feelings as to like, oh, this one was way easier doing it this way. Sometimes I'll give you the choice, and sometimes I will not. So just keep that in mind. All right, what we're going to do is one side of the equation is like one function. So the square root of x, we're going to graph it. And then the other side of the equation is another function, and we're going to graph that. And then the idea is where these functions intersect, that is the solution to this equation. So if I graph the square root of x, we should have already gone through this lesson before, but remember the square root of x is a graph that starts at 0, 0. And then if we kind of remember our t-tables we made, you could graph any points you wanted for this guy, right? But you want to pick x values that are nice to square root. So like we already did 0. 1 is easy to square root, so square root of 1 is 1. And then 4 is pretty easy to square root. Square root of 4 is 2. So if I plotted all those points and connected, now, one of the major drawbacks to this is if you're forced to graph it by hand and you graph like I do, that means you're awful. So you have to be very, very careful. All right, so the next function, if I were to graph the function y equals 2, that is just a horizontal line at 2. Now, speaking of graphing awful, I just graphed awful. Like, what a surprise, right? But I remember from my work that the point 4, 2 is right there, and that's where this line crossed. And the solution to this is what value for x makes this true. Well, if you think about ordered pair, who is your x? Well, in this case, it would have been 4. But let me show you how this works, okay? On your calculator, which is probably how most of you are going to want to solve this, especially if you graph like me. You type the first side of the equation in y1, so the square root of x in y1, it doesn't really matter which one's first or second. And then the other side of the equation in y2. And then when you look at the graph, you're going to look at a much better picture of where they intersect. Now you don't even have to like squint and figure out where they intersect just with your eyes. You can make the calculator find it. So go to what's called the calc menu, so second, trace. And then number 5 is called the intersect. So it's going to say, is this your first curve? And you say yes by hitting enter. And then is this your second curve? Yes, hit enter. And then do you have a guess? You don't even have to guess because it's close enough. It'll find it automatically. Hit enter one more time. It'll think for a minute and then pop out the ordered pair 4, 2. So just remember when you're solving an equation and it says solve for x, just give the x value. I already knew the y was 2. That was the whole point of the other side of the equation. So the answer to this question is x equals 4. Now, some of you are going back to the original question and going like, yeah, of course x equals 4. Because if I squared both sides, I'd get x equals 4. Again, drawbacks and advantages. It's a little more tedious, but it definitely doesn't require much thinking, that's for sure. All right, not that I'm promoting not thinking, you know. All right, the next problem, whoops, get out of there. We're going to be graphing the square root of x plus 6 on one side, and then x on the other. And I think I learned my lesson about, like, Abruzzo, you can't graph. Why are you even trying, girl? So I'm going to go ahead and, you know, do this. I forgot what the function was, though. X plus 6 and x. Okay. Burp. Plus 6. All right. So now when I hit graph, and I would like you to kind of take a moment to sketch this on your graph. I guess I could too, huh? So y equals x, square root of x plus 6. We're going to find the intersection point. So go ahead and pause the video, take a moment to sketch both of those, and you probably have an estimate for where you think they intersected. Let's find it. First curve, enter. second curve, enter. Do you have a guess? Nope, hit enter. 3. So the solution to this equation is that x equals 3. So if you're going to utilize this method, I'm going to expect you to obviously have your calculator handy, but you're going to have to sketch this, okay? I know that seems like, ugh, why do I have to do that? You just do. Yeah. So you're going to do a much better job than I'm about to do, but you know, something like this. And then you're going to show the intersection of, you know what, that wasn't too bad for me. I've done way worse than that. Okay, so 3, 3, the answer is x equals 3. All right, so here we have the cube root of x minus 2, and then equaling a negative 1. So solving this via our calculator intersection. I already forgot what it was. Cube root x minus 2 and negative 1. So cube root is in the math menu. I already forgot it. I think it was minus 2. I'll have to double check though. And then negative 1. Make sure you use the negative symbol. If you use a subtraction sign, it'll yell at you. Say it was an error. Yeah, totally remembered. Okay. So there's the cube root. There's negative 1. They only cross once. I will warn you that there is a possibility of them crossing more than once. All right, so calc. Find the intersection. Enter, enter, enter. Mine takes a while. X equals 1. So again, we would have to take a moment. Please pause the video and draw both of those functions. Do a better job than I just did. Actually plot points. Remember your table? I'll give you some good points. Oh, so bad. All right, x equals, was it 1? I already forgot. My goodness. I think I need to take a break or something. Yeah, x equals 1. All right, it's really late at night. I'm really tired. Okay, this next one, the cube root of x, then x. Alrighty. Cube root of just x, so let's delete that. And then x. All right, let's see what happens. I warned you there might be 2 intersections, huh? I didn't warn you there might be 3. All right, I think we need to zoom in a little bit here. Go to the window, and I want you to shrink down that window quite a bit. Let's just go like -3 to 3 for x's, and let's go -3 to 3 for y's as well. Shrinking it down. You could zoom in. That was another option to go zoom and then in. Okay, so there's that cube root function. And then there's that linear function. And can you tell that this crosses 1, 2, 3 times? You have to find all of them. Now, if you can already kind of estimate where they are, you already figured it out, like you can skip this step. But if you want your calculator to find it, you'd go to intersect, and then enter, enter. When it says guess, it's going to go to whichever intersection point it is closest to. So clearly it is closest to where it's at right now. So it's going to find that one first. So one of the solutions is x equals 0. Jot that down. You got to go through these steps all over again. So intersect. So first curve, enter. Second curve, enter. But this time, before you hit guess, and if you already hit guess, just pull it up again. You have to scroll towards one of the other solutions. So get closer to a different one. And then hit enter. -1. Take a wild guess what this one is, guys. That's right, it's +1. Okay, so if you have 3 intersection points that you have to find, the drawback to that is you do have to find them separately. So one of the solutions was x equals -1, x equals 0, and x equals 1. So please pause the video and take a moment to graph what you saw here. I know -10 to 10 wasn't the best window. All right. Uh-oh, there's one coming up with a star on it. That's not good. Let's look at this next one. I'm going to graph the square root of x, and then +2 is outside of the square root symbol, and then x is going to be my other function. So just type carefully. Oh. Clear that out. All right, square root this time. So x, get out of the radical, and then hit a +2. And then, lucky me, I already had the second function in from the last problem. Windows all stupid, right? So let's hit zoom 6 to bring us back to the standard -10 to 10 window. Okay, there's going to be one intersection point. Let's make my calculator find it because it's like super late at night and my eyes aren't working anymore. All right, first curve. Yes, enter. Second curve. Yes, enter. Do you have a guess? Nope, I don't care. Enter. Answer is 4. X equals 4. All right, so please pause the video, take a moment, and sketch what both of those ended up looking like. Okay, this one will be fun. Number 6, stars. That can't be good. All right, let's take a look. And you can graph in each side of the equation exactly how it looks. So square root of x minus 4 plus 3 on one side and then 0 on the other. Okay, I gotta remember that. Minus 4 plus 3. Okay. Square root. I already forgot what it was. X minus 4 and then plus 3 on the outside. This is where when I'm teaching in class, the kids tell me what to do because I can't remember anything. And then 0 would be my other function. Double check. Nailed it. All right. So when I hit graph, the blue and the red. So there's the blue. There's, oh. Uh-oh. So the whole point of it is to find the intersection point. These are not going to intersect. Like that blue curve is not going to come back down to the axis. So I guess my question for you is, what's our solution? And your answer should be, well, Abruzzo, there is no solution. So again, pause the video, take a moment and sketch what you graphed. And then we're going to write down that there is no solution. Now, I don't even think we had to do that much work, guys. Think about this. If I were to subtract the -3 over, just do a little bit of algebra with me. It's asking when the square root of something equals a -3. Think back to when we did this last unit. Can a square, well, we did absolute value, but the same idea. Can you square root something and end up being negative? Not in a real number system. So, yeah, that'd be a no solution. All right. I said that kind of weird, but anywho, life is good. Oh, heck. This is probably your homework. I bet you're wishing I'll do this homework for you. I'm not going to. So best of luck to you. This is probably one of the last things we did in this unit. We're about to start the quadratic unit, which is like amazing. And you also might notice that we have a lot of time left in the semester and just one more unit to go. That should kind of tell you how big this next unit is. It's going to be great.